Good morning. How we doing, friends? All right, we've got arithmetic sequences day 2. We are going to take a look at word problems with arithmetic sequences. Essentially, we're taking the same thing we did the last day, but we're putting context around it, and we're applying that context. In order to dig in, we've got to refresh our memory about what the explicit form of an arithmetic sequence is. Remember, it's that expression, that equation, a sub n equals a sub 1 plus n minus 1 times d. Now we use this as a formula where we put things in those two spots. We calculate the equation that allows us to generate the sequence or the numbers in a row that come up in the number pattern here. A sub 1, let's define what these different parts are. A sub 1 would be the value of the nth term, a sub 1 meaning the first term, n meaning the term number, and d meaning the common difference, which is similar to the slope, could also be called the rate of change. All right, let's dig in. Examples. There are 20 seats in the first row of a balcony of the auditorium. There are 22 seats in the second row, 24 seats in the third row. Write a function to represent the sequence. Another way to say part A would be write the explicit form. Write a function that represents the sequence. The explicit form, that means use the formula that generates the equation for the arithmetic sequence. So we have to look at the description of the problem. There are 20 seats in the first row, so we're going to just say 20. In the second row, 22 seats. In the third row, 24 seats. And I think we could take a look to see that this is an arithmetic sequence that continues, so on and so forth, until we fill up the balcony. So we have to, when we look at the sequence, we have to look at it and we have to say, okay, what is a sub 1? A sub 1 meaning being the first term, which would be 20. So we're going to put that in the 20 spot. We're in the a sub 1 spot, plus n minus 1. We don't mess with that stuff. Now we look at the common difference. So like, how do we get from 1 to the next? It's a plus 2. So that is d. And we simplify this and get our function that represents the sequence, or the equation that would generate the sequence. So we do 2 times n is 2n, 2 times negative 1 is negative 2. Continue to solve it. So we get 2n. When we combine like terms, we get plus 18. So this, friend, this is the explicit form, or the function that represents the sequence. So now when we ask the question, how many seats are in the 10th row, that's the number, that's the term number. We're looking for the 10th term number. So that becomes n equals 10. And we use our equation up above to generate how many seats are within that 10th row. We put 10 in there, and we're going to evaluate it. 20 plus 18 would be 38. So then so the 10th term is 38. So what I'm going to say is there are 38 row seats in the 10th row. I'm going to put it back in context because it's a word problem. We have to explain it in its context. Okay, great. Let's take a look at Sarah. Sarah learns to knit from her, number 2, Sarah learns to knit from her grandmother. 2 days ago, she measured the length of the scarf she is knitting at 13 inches. 2 days ago. Yesterday, she measured the length of the scarf at 15.5 inches. Today, it measured 18 inches. So it looks like we have a pattern, a number pattern, or a sequence that starts at 13 being the first term, going to 15.5 going to 18. Let's check to see if we add the same thing each time. So it's 2.5 there. Again, 2.5. It looks like we have a common difference of 2.5 in this particular arithmetic sequence, or this particular sequence of numbers. We also have an a sub 1 of 13, meaning the first term. Now, if we are writing a function to represent the arithmetic sequence, we're going to use our closed form for arithmetic sequence, or our explicit rule. And we're going to use that as a formula. We're going to put these two pieces in and simplify it. So a sub 1 being 13, we leave the n minus 1, d being 2.5, and now we continue by multiplying this in. We get 13, a sub n equals 13 plus 2.5n minus 2.5. Continue to simplify. A sub n equals 2.5n plus 10.5. That would be our explicit form of our arithmetic sequence, or the function that represents the arithmetic sequence. Now, how long will the scarf be after day 7? If you remember, day 1, or day 2, day 3. So we want what happens when n equals 7. We're going to evaluate our function for n equals 7. So a sub 7 equals 2.5n plus 10.5. Oh, instead of n though, we want a 7 there because we're talking about what happens in the 7th day, or the 7th part of the sequence. So a sub 7 equals 17.5 plus 10.5. So a sub 7 equals 2028. So we put it back in context. The scarf will be 28 inches long after the 7th day. Okay, now let's go ahead and look at C. When will the scarf be 58 inches? Well, if you recall, the inches was the value of the term number, the value of a specific term. So how big it would be after a certain amount of days. So this is not our n anymore. This is our a sub n equal 58. And what we're looking for, we're looking to find the day. When will the day that the scarf will be 58? So what we do is we have our formula, a sub n equals 2.5 n plus 10.5. And we have the scarf being 58 inches, so that's our a sub n, and we solve this equation for n. When we do that, we'll find the day when the scarf will be 58 inches. So now we're going to minus 10.5 minus 10.5. So that gives us 47.5 equals 2.5 I n. And now we're going to divide by 2.5, divide by 2.5. You know what that? So it would be 8, 11, I believe. I think it's 11, but I'm going to just drop it into a calculator real quick because I don't want to make it. Oh, wow, it's 19. I can't believe I said 11. Maybe it's too early in the morning. So 19. So n being 19. So let's put that in context. So after, or scarf would be 58 inches after on the 19th day. Back in context. Okay. Let's look at number 3, friends. All right, let's dig into question number 3 with us. So we're going to break it apart into those two components again. Is this an arithmetic sequence? So number 3, After knee surgery, your trainer tells you to return your jogging program slowly. You suggest jogging 10 minutes the day after treatment. Each day thereafter, he suggests increasing that time by 2 minutes. Is this an error? Well, if we start at 10 and we go up by 2 on the amount of minutes we train, yes, it would be an arithmetic sequence with a common difference of 2. Okay. What is the first term? The first term on this, though, would be 10 because the first day you don't jog. So we're really starting on the second day um, if we keep it in context, meaning the first term would be 10 in this case. What's the common difference? We said it would be 2. Write an equation for the arithmetic sequence. We have our a sub 1, we have our common difference. We can write our equation using our formula, and we drop our values into that formula. A sub n being 10, n minus 1 staying the same, because that's part of the formula, times 2 being the common difference. We distribute, simplify. We get a sub n equals 2n plus 8. So this is then the formula that would help us determine the amount of minutes we jog each day. Okay, so how many minutes are you jogging? Are you jogging 20 days after your visit to the trainer? So remember, the first day after the visit from the trainer, that's when we started for 10 minutes, okay? So this would become 20 and would become 20 for 20 days after the visit to the trainer. So we put that into our explicit form and we evaluate it. So a sub 20 equal 40 plus 8, a sub 20 equal 48. So 48 minutes of jogging. Okay, let's talk about that. How many days after your visit to the trainer are you jogging for 30 minutes? So now this is not n anymore. This is a sub n. This is the amount of minutes jogging. That's the value of the term. That's the term value in this context. So that becomes a sub n. And we use our formula to evaluate or to solve for n now. So we put those two together. So 30 equals 2n plus 8. And we solve it for n. We get n is 11. So after or the 11th day after the visit, you jog for 30 minutes. Okay? Okay, friends, that is what we are going to end at. We're not going to finish this one, which is totally okay because it's just about the same thing as actually, yeah, it's just about the same thing as the other one. So enjoy the rest of your day and thanks for taking the notes and we will see you later. Peace, friends.